I'd like to, could you see my screen? I'd like to briefly introduce today's introductory courses. Uh, uh, we, we are at the first item. I'd like to briefly introduce our platform and core technology in 30 minutes, and then I will give you the EEG rhythm generation mechanism, and you can understand alpha, theta, delta, beta rhythm. And this EEG rhythm is associated with the neurotransmitter, and we can understand brain subsystem using the neurotransmitter and EEG rhythm. And after that, I will either took another another 30 minutes, and then I can give you the iSyncWave easy recording and understanding of the quick summary. Before going to the recording, I'd like to briefly give you the 10-20 system and montage concept. And after iSyncWave recording demo, I can explain what is the good recording, what is the bad recording, and give you the how can we use the EEG quick summary and HRV summary after the iSyncWave recording. And then it took another 30 minutes, and then I will give you the QEEG understanding with the iSyncBrain. We can understand FFT and power, and we can also understand the AA denoising and component. And using the interesting cases, we can understand iSyncBrain QEEG analysis in detail. I will use the MCI mild cognitive impairment case and depression case. And if you have time, I will give you the sleep disorder cases. It will take an hour. After understanding of the QEEG concept, we can design the QEEG guided photobiomodulation. Before final chapter, I will give you the mechanism of the first frequency selected transcranial photobiomodulation and how to combine the QEEG and the photobiomodulation protocol design. It will take another 30 minutes. I think all together, I think it will at least 3 hours and 30 minutes, around 4 hours. I think it will finish 6 o'clock. After each chapter, we can get the small Q&A session and small break. But during the presentation, you can always interrupt and ask a question. And yes, and this is the today's title and the platform for the QEEG guided neuromodulation. I already this is the today's topic, the platform and iMediSync core technology and generation mechanism, and what is the quick summary, and how can understand QEEG analysis, and how we can integrate QEEG and PBM protocol intervention design. And that's today's topic. And first, I'd like to introduce the iMediSync platform and the core technology. This is as you know, we have the two devices. One is the FDA cleared device. Second one is not FDA cleared, but we can use as electronic device. Using this portable EEG scanner, and we can record 19 channel EEG recording, and also we can record HRV. HRV is heart rate variability. In the first model, we can call the iSyncWave. The second model, iSyncB. iSyncWave, and we have the right ear PPG sensor. Using that sensor, we can collect HRV at the same time with the 19-channel EEG. In the iSyncB, we have the PPG sensor on the forehead. In the center of the forehead, we can record PPG and we can calculate HLB. And using that recording system, we can analyze the brain QE, quantitative EEG using iSyncBrain, the FDA-approved software medical device. And we can also analysis the HRV. All the EEG and HRV analysis calculated and compared with the health normative database, age and sex matched health normative database, and we can get the this kind of color coding of the with the G score. How this client is different from the health normative data. And we can give the EEG analysis and HRV analysis using the normative database, and then we can give this kind of many biomarker. Currently, we can give the MCI biomarker. If our client have the probability over 60%, that means the client will have the MCI. And we are developing the Alzheimer detector and Lewy body detector and depression detector. And we can combine the QEEG analysis and this kind of biomarker analysis for the client. And combining this QEEG result with the photobiomodulation to make a precision personalized neuromodulation. And we can give the photobiomodulation using the same device. That's our iSyncBrain personalized AI mental care platform from measurement and analysis and neuromodulation. And now we can use this device as a wellness device, not medical device too. And this is the basic service structure. Once recording the EEG and PPG signal, and after the during the recording, the EEG and PPG signal transmitted using the wireless Bluetooth protocol, and real time we can monitor the real-time signal quality in the application. After recording the EEG and PPG data, it goes through, go to the cloud through the Wi-Fi. And once the data arrived at the cloud, the first process is the AI denoising. And after the denoising, we can make the clean 19-channel EEG data and the PPG data. And using that kind of clean data, and we calculate the quantitative features, EEG features and HRV features, and then compare with the normative database. And we can go through the biomarker analysis. Finally, for example, after 10 minutes usually, and we can get the quick summary report. And using the quick summary and the QEEG profile, we can give the personalized neuromodulation. The core technology is the normative database. And, as you know, the EEG normative database basically culture-free, but male and female is very different. So we developed the sex-classified normative database. That's the first one, first normative database. It's sex-classified in the world. And the second core technology is the cloud-based EEG analysis. Our EEG analysis is specialty is the AI denoising. We can make the clean data without manual, without labor-intensive manual processing. But sometimes the AI is not perfect. In that case, we can do the manual denoising for when the AI denoising is not perfect. But basically, we keep the automatic analysis using that. So many clinicians can take advantage of this kind of automatic QEEG analysis. And third, our core strength is this kind of AI biomarker analysis. In the EEG world, the time dynamics is very important one. same EEG rhythm, theta rhythm, gamma rhythm, beta rhythm itself, uh, uh, the dynamic dynamicity of that rhythm is very important. For example, usually the the dynamic pattern is very healthy, and the persistent rhythm pattern is not healthy usually. Using this kind of dynamic pattern, we developed the AI biomarker for many kind of diseases. And this is the our wireless helmet integrating the EEG function and PBM function at the same time. uh, this is I will briefly introduce this core technology a little more detail. The health normative database, as you see here, the total number of the health normative. Actually, we recruited the 1,800 normal population, but we all the population we went through psychological, emotional, behavioral evaluation, and 1/3 of the population is rejected as the healthy normal. So finally, we have the 1,289 healthy normal population. This population from age 4 to 84 and divided by uh, the male and female like this. And the child and adolescent is about uh, 617 and adult population 675. And this is the healthy EEG normative database first classified as sex. This is our main specialty. And the before going to the second part, second core technology, we need to understand EEG a little bit briefly because there are many different background of the participant. I'd like to briefly introduce EEG rhythm. I will explain in more detail in the second part. EEG rhythm we call the beta rhythm, alpha rhythm, theta rhythm, and delta rhythm. This is the real amplitude. Y-axis is real amplitude. X-axis is the time scale, and the beta rhythm is very fast rhythm, usually frontally and parietal. And this beta rhythm divided by beta 1 to 3. Beta 1 is calm focus, 2 is the active focus, 3 is over focus. The alpha usually occipitally, this kind of amplitude. The amplitude is bigger compared to the beta rhythm. The alpha, when we drowsy, the alpha rhythm decrease like this. And after this is the alpha usually represent the relaxed status. And after person go to the real drowsy, the theta start like this. And this kind of persistent theta is could be the drowsiness, and but some kind of phasic, very transient theta is the associated with the memory retrieval process. After 4 years old, alpha frequency reached the 8 hertz, and after usually 14 years old, the alpha arrived at 10 hertz in the average adult level, but usually uh, very young children, theta is dominant. And you can see the delta. And the delta theta decrease as children develop, and alpha eventually um, eventually start to increase. That's the age-related change of this rhythm dynamics, rhythm development. And we can understand this kind of easy rhythm using this kind of frequency and amplitude charts. This is the frequency. If the frequency increase, the amplitude usually is drop like this, because the low frequency usually high amplitude, high frequency usually low amplitude. That's that because the low frequency recruit a lot of neuronal population, very large scale neuronal population, and high frequency activity usually recruit very a small number of the neuronal population. So the low frequency activity usually high amplitude, high frequency activity usually low amplitude, and also and our skull usually the high frequency cannot cannot transmit. Usually frequency is higher. The permeability of the high frequency activity is very low. The high frequency activity drop rapidly. Combining these two effects, the usually high frequency activity is very small amplitude. This is the amplitude and frequency relation. And this kind of relation, a little bit uh, moving to the right when we concentrate, and when we relax, this kind of frequency distribution moving to the left when we relax. So when we concentrate, this relation move to the right. That's the basic concept of the EEG frequency rhythm and the amplitude. So we developed this kind of the second input. Our first strength is normative database. You can see the delta decrease with age like this. The theta also decrease with age, and alpha and beta and dynamic pattern. This is the absolute amplitude. In the relative, the delta decrease, theta decrease, and alpha increase uh, and saturate, and the other level. In the beta also increase and saturate in the other range in the relative power. And this is the absolute power. So alpha and beta is dynamic pattern. And usually this kind of age-related rhythm amplitude, or we can use the power, this kind of delta rhythm decrease and alpha and beta, this kind of pattern. This is the red and blue is the male and female mean changes, and the shaded area is the standard deviation. Using this kind of normative database, uh, we can give the we can give the what's the difference from how many different from the health normative population. And you can see also in the male, and this is the male and this is the female, and male and female difference. You can see male and female is the difference in the young group, and male and difference in the adult group is quite significant. You can see this kind of sex difference is very substantial compared to the uh, ethnic difference. I have four waiting participants. I'd like to include them. And the second important specialty is our AI denoising, automated denoising. EEG is a quite useful signal, but actually EEG is not so popular because the denoising is very difficult, because it takes a lot of signal processing algorithm. It is not automated, so many researchers uh, do the cleaning process before understanding the EEG pattern of the research group or the clinical population. So a lot of labor usually due to the lot of labor-intensive work of the manual denoising, so many people cannot use the QEEG very much. But we give the automatic denoising, so all the high signal processing technology integrated on the cloud. So the EEG very susceptible of the recording noise artifact. that kind of artifact, usually having the specific pattern, using that specific pattern, AI trained very well, and we can make the clean data without labor-intensive manual process. So using this kind of the AI denoising algorithm, we can make the clean data automatically, and then we can take advantage of the high potential of the EEG and QEEG information. And that's the our second specialty, and the third one is our biomarker analysis. After calculating the QEEG features, there are a lot of QEEG features. So clinician usually need to review all the QEEG pattern and parameter, but using this kind of biomarker, we can simply detect the MCI population. This is the power of the biomarker, and using this kind of MCI classifier, we can get the MCI possibility just after recording these data. We can get this value when we have when the client having over 60%. That means MCI. This is the special core strengths of our company. We can use M1 MCI classifier after recording the EEG using iSyncBrain, and we are now actively developing the amyloid detection. Is a little bit different from MCI. This is the pathophysiology detector. When people having the amyloidopathy, they can have the specific EEG pattern. Before going to the very high cost amyloid PET imaging, we can screen out possible amyloidopathy population. We can call Alzheimer's disease. We can screen Alzheimer's disease population using the quick 5-minute scan. And another important one is the Lewy body differentiation using the same QEEG profile. Lewy body and amyloidopathy has different QEEG profile. We can separate these two. That's another specialty. And we can also screen the high risk depression population using this kind of depression screening biomarker. At the moment, we only service M1, M2, 3, 4 will be integrated one by one after we finish the clinical study. And recently, we integrate the developmental age biomarker in our report system. M5 is already in service. As you see here, our brain develop linearly. For example, the child and adolescent, the height is increased. At the same manner, the brain is developed like this: frontal lobe, temporal lobe, the parietal lobe, the occipital and lobe is developed rapidly before age of 20. So using that kind of rapid developing in the child and adolescent period, using that kind of rapid developing, we can make the biomarker of each brain area. So now we are doing AI developmental age service in our service platform. You can use this brain age biomarker on the 20 years old child and adolescent. And finally, our core strength is this kind of brain scanning and LED PVM integration device. Using this device, we can give the quick standardized way of the EEG recording. This device having specific mechanical structure. Once we align this kind of the frontal this kind of a frontal line and temporal line, then 19 standard positioning is automatically we can make using this special mechanical structure. So I think this is the another specialty of our dry ease headset. Specific gear structure make the proportional expansion when while the maintaining the substantial suitable contact pressure in each electrode position. So the automatic positioning is the specialty in this device. Recently, we developed one more device. It is as you see here, that this second device uh, can cover under the 50 centimeter head circumference. Usually 6 years old, the children record EEG using this device, but under 6, they cannot record using this device. Their head circumference is too small, then we can use this device. And this device is more lighter compared to this one. So basically, we can use this device and this device both both ease recording and PBM function. But at the moment, this is only the medical approved device, Korea and US. And a little bit difference of these two devices is the optical power. Optical power is, I think, me is a little bit higher optical power. That's the other difference. So we can use both this device. And recently we developed very high coating durability. This is the misspelling, AgCl. Silver chloride is very high quality material for the EEG recording. But our current electrode suffer from the less coating durability. So we developed the second high coating durability electrode. We will release this high quality coating durability electrode. Usually, after 100 and 200 recording, the coating of the electrode usually worn out. Then you should replace the electrode. But the new electrode, we think we can take advantage of the more durable silver chloride electrode system. Do we have any comment in the first part and question? You can interrupt during the presentation, and I'd like to briefly go to the second part, the generation of the EEG with the iSyncBrain demo. It is very important to understand how the EEG rhythm is generated. So I'd like to introduce the EEG generation mechanism. Usually we have the trillion neuron and 1,000 trillion synaptic connection and billion trillion neurotransmitter releasing and absorbing. It is corresponding to the computer capable of the trillion gigabyte per second in the 106 kilogram of the brain, with the consumption of the pico, 1,000 of the pico-watt. Very efficient system. So the usually brain compared with the universe, wider than the sky, wider than the universe. It is very complex system, but actually the brain rhythm generates from that kind of complex system are very simple. The EEG rhythm itself is very simple pattern. So that's the beauty of the EEG rhythm, I think. the EEG rhythm coming from, before going to the EEG rhythm, there are two different kind of uh, cell in the brain. One is the neuron, the second, other is the glia. There are two different cell in the brain, the neuron and glia. And as you see here, this is a neuron, and and the you you see this is the oligodendrocyte. This is the we also call the myelin. Myelin is the kind of glia cell, and in the microglia is another kind of glia cell. Astrocyte is glia cell. Glia is very important. Glia is the supporting structure of the neuron, and the neuron, you can see this kind of long axon and dendrite and the neuron cell body. And this neuronal axon covered by the myelin, this is the very important one for the information processing between two different neurons. So the once we develop from child from age from birth to age 4, the before age 4 we don't have the alpha frequency, only theta. But during the development, this kind of myelinization make the neuron-to-neuron communication more faster. That makes eventually alpha rhythm. So glia is very important one. And in the EEG rhythm, delta, theta, alpha, beta rhythm, under the delta rhythm, there are very slow rhythm. Below 1 hertz rhythm, that rhythm is also very important one. That kind of slow rhythm made by glia, and from delta, theta, alpha, beta, gamma, this rhythm generated by the neuron. So glia neuron also make the electrical activity, and we focus on only the neuronal EEG rhythm from delta to gamma. Today I want to focus on this neuronal EEG rhythm. I mentioned before the EEG alpha peak. This is alpha peak frequency. Some participants do not understand alpha rhythm very well, but I will explain in the later. And alpha frequency, this kind of 10 hertz is the adult alpha rhythm. During the myelinization, the alpha speed going up, and finally on the age 14, the alpha rhythm go to the adult range. This is the developmental curve in the child and adolescent. And using this neuronal communication, we can make this kind of different frequency brain rhythm. And in the neuron, there are two different kinds of neuron: the non-pyramidal neuron and the pyramidal neuron. Pyramidal neuron, you can see you can see this kind of pyramid shape is the pyramidal neuron, and another one is the non-pyramidal neuron, usually mediated by GABA. GABA is the inhibition neurotransmitter. Our brain usually inhibit overall using the GABA, and the brain rhythms, delta, theta, alpha, beta rhythm is mediated by each neurotransmitter: dopamine, serotonin, norepinephrine, acetylcholine. This kind of neurotransmitter we can make the brain rhythm. And so the usually pyramidal neuron makes the EEG rhythm. You can see the pyramidal rhythm, non-pyramidal rhythm showing the short connection, but the pyramidal rhythm very long connection. For example, alpha rhythm made by the pyramidal neuron coming from the thalamus and cortex, and then thalamus again. Thalamo-cortico-thalamic long loop. That kind of pyramidal neuron, very long distance connection, we can make the alpha rhythm. So the pyramidal neuron usually makes the theta, alpha, beta rhythm, and the non-pyramidal neuron usually make inhibition in the brain system. And here you can see the in the pyramidal neuron there are long distant axon, and you can see the long distant axon. There are a lot of uh, ion going in and going out. A lot of ion influx and outflux make a lot of potential, but this kind of propagation, the action potential is cancelated each other, but only the action potential cannot make the EEG rhythm. Only this axon and another dendrite make a synapse, and after making a synapse, this kind of postsynaptic potential uh, uh, generated. This postsynaptic potential and synchronously generated through the thalamic pacemaking that makes the alpha rhythm. So many big assembly of the neuronal column from the thalamus to the cortex. The thalamus act as a pacemaker. That kind of thalamus to cortex projection, the synchronous the synchronous the synchronous activity of this postsynaptic potential makes the measurable EEG rhythm on the skull. That's the EEG generation basic mechanism. So as you can see here, usually the pyramidal neuron arranged in this kind of highly ordered fashion. So this kind of highly uh, ordered structured pyramidal neuron uh, made by the synchronous activity from thalamus pacemaking that makes a very big alpha rhythm at the skull skull. That's the basic generation of the EEG rhythm. Uh, Alpha made by the thalamocorticothalamic loop, very long loop, and theta made by the limbic loop. Limbic is another medial structure, and anterior cingulate and hippocampus, parahippocampus, that anterior cingulate, posterior cingulate, that makes another limbic circuit. This limbic circuit, long distance of limbic circuit, make a theta rhythm, and thalamocorticothalamic is make alpha rhythm, and the cortical seat dipole making a delta rhythm, and more close that network makes a beta or gamma rhythm. That's the generation mechanism of the EEG. And you need to understand the basically brain primary mechanism is inhibition mediated by GABA. Please mute the mic during the presentation.
รบกวนปิดไมค์นี่ครับขอโทษนะครับปิดไมค์ด้วยครับ
Okay. And we need to understand basic mechanism of the brain is the inhibition mediated by GABA, and the rhythm, alpha rhythm, theta rhythm, beta rhythm generated when this kind of inhibition is relaxed. And the thalamocortical rhythm or cortical rhythm, thalamocortical rhythm make alpha, and limbic cortical rhythm make a theta, the cortical rhythm make a beta or gamma. So this kind of thalamocortical or cortical reverberation allows a easy rhythm, and some rhythm makes at the cortical level or thalamic level. Important one is the many big number of the neuronal population oscillate in synchrony, make a measurable change of the rhythm. So that's why thalamic pacemaking is very important one. And this kind of EEG mechanism make a different rhythm in different location and make a connection between two different areas. And this is the EEG general EEG generation mechanism. Before going further, I need to briefly give the whole picture of the brain system before going further. The brain is very complex system. As I mentioned before, trillion neuron and 1,000 trillion synapses and billion trillion neurotransmitter absorption and release. They're very complex, but basically our brain system is very simplified like this. Our brain system is basically the attention system. And some information, when we saw the new thing, when we see the new thing or hear the new sound, that makes our attention system working. For example, our brain system is basically attention system. Something new, we can attend. Something not new, we did not attend. That's why our brain system is basically an attention system. And the information is meaningful for us, then we need to memorize that information. That's why after attention system, we need to memorize that information. So our brain system is basically attention system and memory system. When we memorize some information, we need to attach affective information too. Some information is very good for me. Some information is very bad for me. So memory and affective system wired together usually. So affective system and memory system is mixed together. So after attention system and the information is going to the memory system. And once we get the memory, based on that memory, we made a further decision based on our previous experience. So based on that memory information, we select our action. That's the executive system. So our brain is basically attention system and memory and affective system and executive system, and basically inhibition system. So inhibition system mediated by GABA, memory system mediated by acetylcholine, and attention system mediated by the norepinephrine, the affective system mediated by the serotonin, executive system mediated by the dopamine. So this kind of neurotransmitter and brain system uh, uh, is very important connection we need to understand. And each neurotransmitter make a special brain rhythm. For example, dopamine makes beta rhythm. When we have the dopamine deficiency, our beta rhythm decrease and the theta rhythm increase. Continuously arrive a new participant. So, and the serotonin system makes alpha rhythm, but serotonin deficiency, when we have the serotonin deficiency, the alpha usually strong in the back of the head, but serotonin deficiency, alpha diffuse in the frontal area. So frontal alpha is increased abnormally. That is the serotonin deficiency. The serotonin relate to the healthy, strong posterior alpha, and norepinephrine usually relate to the information processing. So alpha is basic rhythm of the brain, and this alpha rhythm make information processing. So frequency of the alpha rhythm is very important, and this frequency of alpha rhythm is mediated by the norepinephrine. And the memory process we use usually acetylcholine. So this kind of if the person having a very slow alpha frequency, we need to give the norepinephrine, and people having the memory system problem, we can boost the we can boost the acetylcholine for the efficient memory processing. So I briefly understand this kind of brain subsystem, and each brain subsystem mediated by the specific neurotransmitter. Each neurotransmitter making frequency specific frequency rhythm. So that's the basic idea we can understand. So before going to the maybe this is the last slide of the second topic, and EEG frequency and the mental status is quite related. So this each frequency band rhythm and the mental status we need to understand. Basically, we have the alpha rhythm during the rest, and this is the cat analogy. Cat and animal having different the similar this brain rhythm. So in the alpha range, that means resting status. When we relax and meditate, and we increase our brain generate the alpha rhythm. And drowsy, the theta rhythm start, and sleeping, the delta start. And in the opposite direction, this is the under-arousal, alpha, theta, delta. In this direction, arousal is decreased. In opposite direction, arousal is increased. We can call over-arousal. Over-arousal. This is beta 1 when the mouse when the cat find the mouse, then usually the cat brain generate the beta 1 rhythm. That means the calm focus without movement. It is very important brain rhythm. And after this calm focus, when the cat catch the mouse, then in that working condition, the cat generate the beta 2 rhythm, not beta 1 rhythm. Beta 2 rhythm is between 15 to 20. That associated with active focus, and the cat sometimes just in case cat cannot catch the mouse and miss the mouse, cat stress level of the cat increase. In that case, beta 3 rhythm is generated intensively. That's the tension, that associated tension and anxiety. And after beta 3 rhythm, there are gamma rhythm, usually between 30 to 45. That is another beta 2 rhythm, very focused, but it is not stressful rhythm. Is usually accompanied by during the cognitive process. Sometimes it means overfocus, but this gamma activity is not similar with the beta 3, and very high correlation with beta 2. So beta 2 and gamma usually associate with active focus or cognitive process, and beta 3 is the tension and anxiety, and beta 1 is calm focus. This is the different EEG rhythm generate the different mental states. it is the brief understanding of the EEG rhythm generation, and each EEG rhythm associated with the brain subsystem and also associated with the mental status. That's the introduction part, and after these two sections, part three, I will go to the iSyncBrain quick recording and how to understand the quick summary report. And before going the third part, we need to discuss a little bit about we can have the Q&A session. Do you have any comment or question?
So, if there is anyone who didn't introduce themselves, then please raise your hand and introduce yourself, or any question or comment.
Hi, Dave. I'm Taksako, and I've got a basic question. And if, as you mentioned before, if the MCI probability score is
Yes.
above 60%, it's a milk mark and of the MCA diagnosis. As you said, so cutoff value it means can we on the basis of that results can we diagnose as a mild cognitive impairment or not?
This is the clinician decision support system, not decision itself.
Yeah.
And using this measure and integrating your clinical outcome, so we can help the clinician to diagnosis of the MCI more exactly. So this is the clinician decision support system, not clinical decision itself. So if you have your client having the probability over 60%, that will very close to the MCI population QEEG pattern.
Oh, yeah.
So you can expect this could be the real MCI. So yeah. Only this MCI value in Korea, this MCI biomarker is KFDA, software medical device, and we give give the introduction to the clinician. This is the clinical decision support system, not decision itself.
Oh, yeah. And you mean it is instead of a cutoff value, you mean it you can diagnose on the basis of that 60% above if the basic is a cutoff value who is 60% above because I have seen many people have 60% above results. So if so, I can diagnose them as MCI or not. It's a very acute opinion, I think. So this I when I say this result is very strict, so many times, and So what sort of opinion should I have on the basis of these results? So every time I'm worrying about
Yes.
that. Yeah.
There are a little difference of the wet recording and dry recording. So are you using the dry EEG headset, our iSync Wave device?
Mm.
Do you using iSync Wave in your clinic?
Mm-hmm.
If you use dry EEG recording, the original clinical study, we used only the wet EEG recording for making this biomarker, but dry and wet are a little bit different. So it takes another difference in the clinical in terms of clinical accuracy, and also the denoising is all very important one. For making a clean data is always important. For before I will give you the demo after this after this part. I will give you a demo before going to the quick summary and MCI result. We need to review the clean data, and once the clean data is perfect, then we can use the quick summary or MCI report. But sometimes clean data is not perfect, then we need to add the manual denoising for making a more reliable data. So the two different factors affect the accuracy of the MCI biomarker. One is the wet-dry recording difference. The second one is the automatic denoising quality. That makes a little bit change in MCI results. So we need to uh, review the clean data first for using the biomarker results.
Yes. Sometimes I seen 75 or for instance 76% probability. At that moment, I must explain that person.
Yeah,
And
yeah, yeah.
you
So
you may have a
yeah,
MCI, and you may not have a MCI. Yeah, I'm very every time very worrying about that is explanation.
yeah. So I understand that. So that's why I add the iSyncBrain case demo example. One is MCI, and the other is the typical depression. So using that two cases, you can uh, combine the MCI biomarker and the QEEG analysis to explain the result to the to your customer, to your client. So I will give you the demo cases in the fourth part. The third part, I will give you iSync Wave quick recording and how to use the quick summary. And after that, I will give you the MCI cases and depression cases in more detail using the iSyncBrain portal analysis item. So that will be a complementary information for explaining the result to the client.
Oh, yeah. Okay. Thank you very much for your opinion.
Yes, I fully understand your perspective. So that's why I add one very typical cases in the post part in today's presentation.
Yeah. Yes. Sometimes 75% above our this probability score, but apparently he or she having no MCI symptom. And in that case, I'm very worrying about that explanation.
Yes, yes.
Mm.
So that's why we need to review the clean data first. And also sometimes we need to review the iSyncBrain portal. There are a lot of analysis items. So we need to look more closely in that specific unexplainable cases. Yes. So that today's lecture focused on the iSyncBrain analysis, how to understand iSyncBrain analysis in more detail. Not just the QEEG summary, EEG summary, and HRV summary. EEG and HRV summary is only for the client, but the iSyncBrain full analysis is very important one for understanding the client, and also very important for designing the photobiomodulation. Only quick summary, we cannot make a photobiomodulation protocol. So understanding the QEEG in more detail is important as a clinician to understand client. Just summary is the very basic material for giving the report to the client. But behind the summary report, there are comprehensive report in the portal. Using that comprehensive report, once we understand the comprehensive report, we can give the explanation and also design the photobiomodulation intervention.
Okay. Thank you very much.
May I ask a question also?
Yes.
About this data of MCI, we also have some problem when we are explaining this result to patients, because the number 50% or 75% or 20%, we can see what it really means for their symptom. And the point is that we get, I guess, and what's the what kind of data AI is working on? I can see what this AI made from the QEEG data. If we could see that difference or border, we can see we can show the patients the data, and we can explain the patient about AI prediction. I guess that's the point of the our problem or question.
Yeah. It only we only give the probability value between 0 to 100. So using only the number, for example, the probability is the 75%. Only that kind of number is not explainable. So recently we need to develop the explainable AI.
Explainable AI.
Yeah, it is not explainable. Only give the number of the probability, MCI probability, but it is not explainable. What kind of EEG pattern makes this number? It is very difficult to find from the current AI model. So the current trend is making explainable AI model. So using that model, we can associate this number coming from, for example, the slowing of alpha rhythm or spreading of the theta rhythm in the frontal temporal area. Usually the degeneration, normal degeneration is the slowing down of the alpha peak frequency, and the frontotemporal alpha increase, sometimes theta increase. That's the usual aging process. But MCI, that kind of pattern more rapidly increasing compared to the healthy normal. That is the explainable AI.
It must be very helpful.
Yeah, that's the new trend of the AI world. But the current model give not the specific specific cause of that number. We cannot it is very difficult to associate which kind of pattern makes this probability. So current MCI biomarker is the very difficult to associate because we have around 100 QEEG parameter combined together to make a decision. So it's very difficult to make a very complex way of combination to make a probability. So it is not so easy. This parameter makes this value in the current model. So I understand your perspective as a clinician. It's very difficult to give the explanation and association of the EEG pattern and MCI result. But there are general trend of the aging process. So that's why in the fourth part of this presentation, I'll give you the MCI typical cases, and using the cases, we can understand the aging process and MCI process more in detail. We can understand more using the cases. And currently, there are a mixture of the pattern combined together in the AI model. So it is not so easy to give you the simple explanation. Between between 60 to 70, this pattern dominate, or between 70 to 85, this pattern dominate. It is not so simple. So it is very difficult for me to give the score related brain pattern.
So we have to learn how to explain or how to read the QEEG of.
Yeah. That will be very helpful for integrating of this MCI score and the full EEG reporting. If you familiar with reviewing the full QEEG report in the iSyncBrain, then you can more easily understand the patient status using the QEEG.
Yeah, okay. You have to use the QEEG pattern for understanding patients.
Right. With this, and not only using this MCI biomarker, but we can also take advantage of QEEG map and combine these two. Then we can more we can explain more better about the patient. That's my suggestion at this moment. So that's why I add one typical example of the MCI and depression in the fourth part of today's presentation.
Okay, we are looking forward to hear from you about the fourth part.
Yes.
MCI.
Yes.
Pattern. Thank you. Thank you very much.
You're welcome. So Dave, shall we have some coffee break?
Yes, 10-minute break will be helpful, and then we can.
Okay, then shall we start again at 3:50?
Yes.
Okay. Let's have a coffee break.
Yep.
Mhm.